Good day. Welcome to another video where we'll be continuing with our test or exam preparation series. So here we'll be doing question 2, question 3, and question 4. But then for now, I'm just going to remove question 3 and question 4 so that I can clear space, right? We're going to do them later. So question 2, we're given a geometric sequence that is T3 20 and then T4, which is 40. And then they say in 2.1.1, they say that determine the common ratio. So we know the common ratio is the ratio between two consecutive terms, right? Which will be T4 over T3. And then this gives us 40 over what? Over 20, which is equals to 2, right? And then 2.1.2, they say a formula for Tn. We know that Tn is equals to A times R to the exponent n minus 1. Of which our ratio we know is 2, but then we don't know what A is, right? But then basically T3 is equals to the first term, which is A times R squared, right? Times R. Okay, and then from that, divide both sides by R. We get that our A is equals to T3 over R squared. And here, for example, let's say maybe we're dealing with T20. Therefore, our A will be T20 over R to the exponent 19. So yeah, they always differ by 1. Okay, and then from this, therefore, our A is gonna be what? It's gonna be 20 over R squared, which is 2 squared, of which this gives us 5. Okay, therefore, our Tn is equals to 5 times 2 to the exponent n minus 1. So we are done with 2.1. And then moving to 2.2. Here we're given a sequence of which the numerator is arithmetic and then the denominator is geometric, right? And then here we, as you can see, we have 2, -1, and then we have -4, and then we have 1, 5, and 25. So how do we determine 2.2.1 when they say right on the fourth term? So here we may start by determining the difference for arithmetic, which is T2 minus T1, which we know is what? -1 minus T1, basically minus 2, right? Which will be equals to -3. Okay, and then now moving into determining T4 for the arithmetic, therefore this will be -4 plus in bracket -3, which is the same as saying T4 is equals to T3 plus D, right? Of which from that we therefore get this being equals to -7. And then let's now look at our arithmetic one. At our geometric one. Our geometric series we have okay, T2 over T1, which will be equals to 5 over 1, which is 5, right? Therefore, this tells us what? That our T4 will be equals to T3 times 5, which is 25 times 5, which gives us 125. Right, and then from that, now we are supposed to therefore determine the actual T4 that tells for. Therefore, T4 will be equals to -7 over 125. Okay, and then the second one, they say determine a formula for the nth term. So determining the formula for the nth term, which is 2.2.2. Here we can start with the arithmetic. We know for the arithmetic we have a plus n minus 1, the common difference, of which our a we know it is 2 plus n minus 1. The difference here was -3, right? And then we have 2 minus 3n plus 3. This gives us -3n plus 5. Okay, and then for the geometric sequence, we have Tn, which is equals to a times r to exponent n minus 1, right? Of which we know our a was 1 times 5, which was our r to the exponent n minus 1, which is the same as 5 to the exponent n minus 1. Therefore, now Tn for the mixed numerator and denominator will be negative 3n plus 5 over 5 to the exponent n minus 1, right? That was our 2.2.2, and then they say determine the 500th term. So 500th term, all we have to do is mainly substitute into the very same formula, of which 2.2.3 T500 will basically be negative 3 in bracket 500 plus 5, okay, over 5 to the exponent 500 minus 1, of which at the top we get negative 3 times 500 plus 5, which is negative 1495. At the bottom, this would give you a math error since it's a very big number, but you can write it as 499, 500 minus 1, right? And then they say which will be the first term of the sequence to have a numerator which is less than negative 59. So 2.2.4, they're basically asking us about our numerator, which is this right here. Let me show you this formula right here for our arithmetic sequence. Like for what values will it actually be less than negative 59? Okay, so for us to do that, we can just say Tn less than negative 59. This in a number line, guys, is basically negative 59 here, and then any number to this to the left, it might be negative 60 is less than negative 59, right? So they're asking us about all of those numbers. So we basically end up with negative 3n plus 5 being less than negative 59, right? Of which from there you can now do your basic mathematics, and we get negative 3n less than negative 64, and then divide both sides by negative, you get n being greater than 64. Inequality sign changes, right? And then divide both sides by 3, we get n being greater than 64 over 3, of which what is 64 over 3? 64 over 3 is basically also equals roughly 21.33, roughly, right? And then therefore we can conclude that n is equals to 22, since the term 22 is the first term that is greater, that is less than negative 59, right? So yeah, that is the answer for 2.2, for 2.2.4, I mean. And then now let's move on into doing question 3. Okay, so for our question 3, we are given an arithmetic sequence defined by w minus 3, 2w minus 4, 23 minus w, and then they say determine the value of w. Okay, 3.1.1, we are given w minus 3, 2w minus 4, 23 minus w, of which we know there's a common difference since it's arithmetic, we are told, right? And then that means that T2 minus T1 basically equals to T3 minus T2 since it's arithmetic, right? This right here is 2w minus 4 minus everything in brackets, guys, so that you don't miss the signs. W minus 3. Instead of you having positive 3 at the end, you might end up having negative 3. I'll show you that in the next step. Okay, T3 is 23 minus W, minus T2 2W minus 4, right? So here we end up with 2W minus 4 minus W, and the negative and negative, positive 3, as I said earlier on, right? And then you get 23 minus W minus 2W plus 4. Okay, therefore here you end up with W minus 1, which will be equals to 27 minus 3W. W is on the same side, you end up with 4W. And then here 28, divide both sides by 4, you get W being equals to 7. So that was it. And then 3.1.2, they say I write down the common difference of this sequence. So 3.1.2, D basically, I will just start it from here, right? But D is a shortcut. D is basically this value and this value, but yeah, it's basically also equals to 7 minus 1, which will be equals to 6. Okay, so we're done with 3.1.2. And then now off to 3.2. They say in arithmetic sequence, has first differences, of which the quadratic sequence the arithmetic sequence is the sequence of the first differences of a quadratic sequence with a first term equal to 3. Okay, so what they're basically saying to us here is the quadratic, let me just write quad here and then arith here. Okay, this is the first term of the quadratic sequence, and then it produces what in arith? It produces 4, 10, 16. This is what they're basically saying. Okay, so here in quadratic we'll have 7, which is basically 3 plus 4, and then we'll have 17. The list goes on, right? And then here the common difference from arith, we get 6, and then we get 6 again, right? Of which from there we know that therefore 2a is this, and then 3a plus b gives us this, and then a plus b plus c gives us 3. Okay, therefore 2a is equals to 6. Divide both sides by 2, we get a is equals to 3. And then 3a plus b is equals to 4, of which this gives us 3 times 3 plus b being equals to 4. Therefore b is equals to -5, right? And then a plus b plus c is equals to 3. This gives us 3 plus in bracket -5 plus c all equals to 3. Therefore c is equals to 5, right? And then from this, therefore our Tn is equals to 3n squared minus 5n and then plus 5. You can substitute the first term to see if the formula is correct or not. Okay, and then the question was asking for what? Determine the 50th term. So here we're gonna say T50 is equals to 3 50 squared minus 5 in bracket 50 plus 5. And then this gives us 3 times 50 squared minus 5 times 50 plus 5, 7,255. Okay, 7,255. So we are done with question 3. And then now off to question 4. Here they say in a geometric series, the sum of the first n terms is given by Sn, right? Of which is equals to P1 minus half to the exponent n, okay? And then the sum to infinity of this series is 10. And then they say calculate the value of P. So 4.1, the value of P basically is, we're gonna work on it now, but okay, let's write down Sn at first. This is P, 1 minus half to the exponent n, right? Of which we know that this right here is derived basically from what? From Sn being equals to a 1 minus r to the exponent n over 1 minus r. And then look at the value of P. You see that basically P is equals to all of these, right? So we can say therefore P is equals to a over 1 minus r, right? Of which also we also know what s infinity, which is equals to a over 1 minus r, we are given that is equals to 10. Therefore, p is equals to 10, right? Since it's also equals to s infinity. Another way of proving it would have been what? We would have used s1 of which is equals to p 1 minus half to the exponent 1, right? Of which here we end up with half p, right, being equals to 8. Therefore, s1 is equals to 8 is equals to half p. We know s1 is the first term. Yeah, okay. And then from that, we therefore say s infinity is equals to a over 1 minus r, of which we are given this as 10. This is half p over 1 minus, we know the ratio is half, right? Therefore, we end up with 10, which is equals to half p over half. Half cancelled. Therefore, p is equals to 10. Right, and then, yeah, we've calculated the value of p. And then in 4.2, they say calculate the second term of the series. Second term of the series is basically T2, of which we know that T2 is equals to A times R, right? Of which our A is equals to what? Half P, which is equals to half of 10, which is equals to 5, right? And then therefore T2 is equals to what? 5 times R, which is half. This gives us 5 over 2. So yeah, that's the end of the video. Thank you for watching the video till the end. Kindly stay tuned. Please like, share, comment, and subscribe. Thank you.